All right, keeper 4.6, Taylor approximation. All right, so basically we can take our Taylor series, and we can write them up to a certain derivative or a certain degree. When we write our Taylor series to a certain degree, we call that a Taylor polynomial. So like if I go to the second degree or the third degree and I stop there, I have Taylor polynomials versus a Taylor series. So like I gave you a few examples here in the slide. So like if I had a Taylor polynomial degree 1, we call that T sub 1, and that would only go up to where it would be linear, so x to the first power. Versus if I had T2 of x, that would go up to the second power, and we would call that the tangent parabola. If I had T3, that would go on to the third power of x, or to that third derivative, and we would call that the tangent cubic. Notice what's very important here is you're not going to that many terms, you're going to that power. So even though it could say T3, you might not have 3 terms. You might only have 2 terms, or you might only have 1 term, but you're just going to the power of 3, or to the cubic power. All right, so example 1, it says write down T2 of x, T3 of x, T4 of x. For the series f of x equals negative 6 e to f of x equals e to the negative 6x about x equals negative 4. So the first thing I'm going to do is I'm going to go ahead and write out my derivatives at x equals negative 4. And so when I do that, I notice that I get e to the 24th, negative 6 e to the 24th, 36 e to the 24th, negative 216 e to the 24th, and then 1296 e to the 24th. And so now that I have that, I can go ahead and build my polynomials. So the first one I want to build is going to be T2 of x. And so T2 of x is going to go to that second derivative, or to that second power. So I'm going to start with the e to the 24th, which is my original function, at negative 4. And then I got negative 6 e to the 24th for the first derivative, times x plus 4 to account for my center. And then it's going to be 36 e to the 24th, x plus 4 squared over 2 factorial. And I just went ahead and reduced that to 18 e to the 24th, x plus 4 squared. Notice I stopped at the squared term because I was trying to find t sub 2. Now if I want to do t sub 3 is going to be all of t sub 2, so all the way to that 18 e to the 24 x plus 4 squared, plus now I have to add that third derivative piece, or that third degree part to it. So the third degree part would be the negative 216 e to the 24 x plus 4 cubed over 3 factorial, which reduces down to negative 36 e to the 24 x plus 4 cubed. Alright, and now when I want to find t sub 4, again, I'm going to do the same thing. I'm going to write all of t sub 3, plus I'm going to add on that fourth derivative piece. Remember the fourth derivative piece, you have to divide by 4 factorial. So 1296 divided by 4 factorial is 54. And so the very last piece of this would be 54 e to the 24th, x plus 4 to the 4th. Notice for each one of the Taylor polynomials that I wrote out, I only went to that indicated degree. I didn't go any further. I didn't put dot, dot, dot. Nothing like that. I stop when I get to the degree that they asked me to stop at. All right, example two, it says write down t sub 3 of x, t sub 4 of x, t sub 5 of x for the series ln of 3 plus 4x about x equals 0. Again, I'm going to start by writing out a few of my derivatives. Notice though that this is a Maclaurin series, so I could technically use a known series to figure this out, but I'm just going to go ahead and continue writing it as a Taylor, so I could do it either way. And so the original function at 0 is ln of 3. The first derivative at 0 is 4/3. Second derivative is negative 16/9. Third derivative, 128 over 27. Fourth derivative is negative 512 over 27 when reduced. And then I have to go all the way to the fifth derivative since they asked for t sub 5. So I have 8192 over 81. Alright, so now to write out my series, I'm going to start with my t3. So I'm going to go all the way to that third derivative. So I have ln of 3 plus 4/3 x minus 16/9 x squared over 2 factorial, which reduces to negative 8/9 x squared. And then the third one is going to be 128 over 27 over 3 factorial, which reduces to 64 over 81 x cubed. Now for t sub 4, I'm going to go that far, plus I'm adding that fourth derivative. So the fourth derivative was negative 512 over 27 But I have to divide that by 4 factorial, which gives me negative 64 over 81 x to the 4th. Now for t sub 5, I'm going to write all of that I had for t sub 4, plus I'm going to add in that 5th derivative divided by 5 factorial, which is going to be 1024 over 1215 x to the 5th when reduced.